Hello world, welcome to the What's New in BI webinar hosted by yours truly, Sam Garrett, live from San Francisco, California. I'm part of the solution engineering team here at Mapbox, where I help our customers build beautiful, useful, and most importantly, performant data visualizations. And so I've been in the BI industry for about 8 years now, working across multiple roles as a developer, product manager, and now a sales engineer. And working across all of those functions, there's been a number of challenges related to location and BI. Maybe you've experienced them too. For example, my map can't handle all of my data, or I need to combine context from my GIS systems with my business intelligence data, or I have too much data on the map. I'm going to show you how Mapbox can help solve some of those problems and more. And so I'm sure we have a diverse audience out there, maybe experienced user of a BI tool, and you're looking for some new ideas about how to make some new killer visuals. Maybe you're evaluating a new BI tool and deciding which one to adopt. Maybe you're building your own BI tool and wondering what kinds of tools are out there for you. Or maybe you're just looking for an hour to kill on a Tuesday. The good news is that I'll have something for all of you out there. And so just like any good BI dashboard starts with context, I wanted to provide a little bit of context about this presentation. Why should you care about maps as part of your BI tools? So everyone's heard this story before, but I'm going to tell you again because the problem isn't going away. Data is getting bigger and faster. For example, Gartner estimates there will be 20 billion connected devices by 2020. Those 20 billion connected devices will be a mixture of IoT sensors, mobile phones, tablets, probably some new technologies that we've never heard of. But one thing that they will have in common is a location context. So you need tools which can handle this amount of location data. And secondly, analytical tools are democratizing BI. It's no longer a specialty role. It's a skill that every employee needs to know. And so the great thing about maps is that everyone can understand a map. And so for those of you that are maybe new to Mapbox, I just wanted to provide a brief context about our company. What Mapbox does is supply tools which can help users with complex location issues. So we're a geolocation API platform which helps users get the most of their data and help answer their most complicated location questions. Sorry about that. Forgot to share my screen. And so as our name would imply, Mapbox, we have maps. And so we at Mapbox like to think that this is more than just showing a few dots on a map. It's providing a platform which can handle millions of dots on a map in the context of your GIS data, in the context of streaming data onto the map to provide updates to the map in real time, providing multiple types of data on the map at the same time at different zoom levels, and much more. And then Mapbox, contrary to our name, is not just a map. We provide a number of other tools to bring context to your location data. For example, search, geocoding and reverse geocoding. Do you have a database of addresses that you want to plot on a map? Our geocoder can take those addresses and turn them into latitude, longitude points that you can store in your database with something like permanent geocoding. And then we have a navigation team as well. So if you think that navigation and ETAs are only for getting yourself from point A to point B, think again. You can use these navigations and ETAs as part of your BI data visualizations to figure out where to build your next store, or how many of your customers live within a 15-minute drive from your store or office. And we actually have a navigation webinar on Thursday that you can check out if you're interested in that. And so today, I'm going to show you the latest and greatest with Mapbox in popular BI tools on the market. I'm going to try to highlight unique features that each of these tools has and what makes these tools special. But you also notice that there's similar features and enhancements that exist across these tools, and that's okay. So I'm going to talk about Power BI. I'm going to talk about Microstrategy. I'm going to talk about Tableau. And then I'm going to talk about some tools that are out there to help you build your own data visualization, which is what customers like the New York Times are doing in terms of, rolling their own data visualization into their website outside of, a standard business intelligence tool. So let's start with Mapbox and Microsoft Power BI. And so for those that don't know, Power BI is Microsoft's BI tool. It's really taken the market by storm in the past couple years. And the way the integration works is through a custom visual, which is on the Power BI marketplace. And at the end of this section, I'll go through with how you can get started using it. So the main differentiator when it comes to Mapbox and Power BI is the ability to do map customization in Power BI. Whether that's importing your own shape files into Mapbox and visualizing them in dashboard, or creating a custom style in Mapbox Studio and using it to provide context to the map, customization is really where Power BI strengths lie. So why should you care about that? Well, whether you've purchased shape files from a third-party vendor like designated marketing areas from Nielsen, or maybe you used ArcGIS and Esri to create your own custom shape files for things like sales territories, agricultural regions, neighborhood boundaries. These can be uploaded to Mapbox and imported into your Power BI dashboard. And Mapbox is the only tool you can use in Power BI to visualize your own shape files. And so honestly, the ability to view custom shape files in Mapbox isn't a new feature, but we've greatly improved the user experience and power of this feature, which is why I wanted to spend some time on it. But in a basic sense, with these custom shape files, you can create area and fill maps, which we have Mapbox called choropleth maps. You can drill between layers of polygons, creating your own hierarchy. And so you don't have to adhere to predefined hierarchies, which other mapping tools kind of force you into. And so if you wanted to create hierarchies that maybe go from state, if you have like a metro area that doesn't fall directly into a state, these are some of the problems that you can solve with building your own hierarchies out. And so the first new feature that we added to these custom shape files and choropleth maps in general is the ability to make your maps pop using what we call 3D extrusions. And these extrusions will be a theme that you see across some of the other tools as well. But in traditional area maps, you're only looking at the boundaries in the context of an aggregation of a single metric. And as is a little bit widely accepted in the BI community, these choropleth maps are often biased towards population density. So adding this extrusion lets you add an entirely new dimension to these visualizations. Possibly allowing you to help eliminate bias by extruding for population, or perhaps providing an additional level of context. So the extrusion allows you to put double the amount of data on a single visualization. And to start using this in Power BI, you simply just drop a metric after you created your choropleth map in the size by field and set your relative extrusion height. And it's also worth mentioning that all the great Mapbox Power BI functionality still works. Lasso select, drill down, cross visualization, filtering. And then the last thing to notice is how the map is pitched. And so now in Power BI and Mapbox, you can set the default pitch of your map, removing the requirement of the user to set the pitch after the visual is loaded. So in this visual, we're looking at internet speeds in the state of New Jersey. Not only can you visualize the download speed, which is what it's colored by, but you can visualize the upload speed as well. And then you can notice how when the visualization is interacted with the bar chart on the right-hand side, that the map's updated dynamically. The drill through to the next layer, which is census tracts, also works well as well. In addition to adding extrusions with custom shape files, the Mapbox map will now automatically zoom to rendered features on the map. In our initial release of this, we didn't have this feature, and it ended up being one of the most highly requested enhancements. And I really don't blame you. It was a big pain point. You'd use a slicer or another visualization to filter down the map. The shapes would update on the map, but the position of the map wouldn't update, and you'd have to manually find the rendered shapes and zoom to them, which doesn't bode well for a good user experience. And so with traditional BI tools, with traditional maps in Power BI, they kind of force you into predefined borders like states and counties and countries. And the auto zoom problem isn't hard to solve in that context because you know the borders of all those countries. But when you add your own custom shapefile, we have to figure that out on the fly and zoom to it. And so this is our initial release of that feature. It's a problem no more, and now our map is much more intelligent and aware of the rendered features. We'll do all the zooming and panning for you. Another great use case of the auto zoom is the map to map cross filtering. And so there's another problem which I've heard from the community, and that's the ability to display a circle layer or a cluster layer or a heat map in the same visual as the choropleth layer. And while we haven't solved that exact issue yet in Power BI, we're getting pretty close. And this auto zoom feature really provides a good workaround for that. And so in this case, you're using the choropleth map to filter an auto zoom to the other map, which has the circle layer on it. So although you use two maps, I could argue that this actually provides a better user experience because you can have more control over navigating the map and the data you want to see at any given time. For example, if I want to select the US, Brazil, and then China, I can do this through one click on the choropleth map and update the circle map, instead of traditionally maybe having to use a drop down or a slicer, which you have to choose one click to drop the slicer down and then another click to select the option that you want. So that provides a little bit better of a user experience. And speaking of enhanced navigation around the map, which is kind of a theme that we've been incorporating into Power BI, we've added a standard search bar or geocoder that we call at Mapbox. So let's take this example. You're looking at this visualization, which is detailing cyclist injuries in New York City, and someone says, that's a really cool visualization of the city, but I want to know how many cyclists were injured around the Empire State Building, or I want to know how many cyclists were killed in Times Square. Would you know Manhattan well enough to scroll to this information to find it quickly? Traditionally, maybe you'd have to cross-reference Google or another source to find this, but now you can simply type your inquiry into the search bar, and the map will automatically take you there. So it's a small but powerful feature. And it's worth noting that the search bar can be turned on or off at your convenience, depending on what type of map real estate that you have. In addition to the geocoder, which can be turned on and off, and slash the search bar, the map controls that you see on the top left of the map and at the top right of the map, the lasso select, the polygons, the zoom buttons, those can also be turned on and off as well. Okay. So the other thing that I wanted to highlight is that on-premise maps can now be brought into Power BI report server. So if you're a government organization, a financial institution, a healthcare company, someone else which has extremely stringent security requirements, if you have an air-gapped environment and you want to use maps, then you can use our product called Atlas Server. Atlas Server brings the entire Mapbox ecosystem completely on-premise, and whether that's behind your own firewall or whether you have your own servers hosted on Amazon or the Microsoft Cloud, Atlas can work for you. And we have a standardized integration with Power BI where you can plug in your Atlas endpoint or your URL. And Atlas itself is extremely easy to set up. It runs in a Docker container, and we have an installer for it. So if you're interested in it, you can definitely contact us to get started. One use case for this in particular is being able to geocode your data and do some data prep completely on premise. So if you have a bunch of addresses that you need to turn into lat longs, but you can't make an external call to a third-party service, then this really solves that problem for you. I did just want to point out really quickly that if you're curious about any of these Power BI demos that we've shown in this section, we do provide you the ability to download the PBIX files locally and see what's going on under the hood. You can just visit this URL. We'll also provide this URL in a document at the end to the attendees, so you don't have to memorize it. And what the PBIX files allow you to do is load these dashboards locally in Power BI Desktop. get more information about how the dashboards were built, the dashboard settings, the underlying data, and see what's going on under the hood. And then just a couple FAQs. The custom visual is open source on GitHub, which means you can clone it down and make modifications if you wish. We always appreciate getting pull requests from the community. You will need your own Mapbox account and access token, so you'll need to go to mapbox.com and sign up for your own account to use it. And the visual is free for up to 10 users to use. So if you want to get started using the visual, go ahead and try that out. And then lastly, all the Power BI data it stays on the all the Power BI data stays on the Power BI environment, and none of the data from your Power BI data model is ever sent to Mapbox. So that's a question that comes up a lot, and I just want to let you know that we're not getting your data. Cool. So that wraps up what's new with Mapbox and Power BI. The next BI platform I wanted to discuss is Microstrategy. Microstrategy has a super powerful integration on Mapbox. And the thing that I love about Microstrategy's implementation is it really combines finite control over many different kinds of layers. And also in the context of provided boundary definitions like global and administrative boundaries, which Microstrategy has baked into the product. Microstrategy differentiates itself by more accurately reading your data and bucketing and aggregating these into geographic regions to display it on the map for you. And features like finite layer control allow the user to achieve effects like intelligent drilling, where as the visual is zoomed in, the boundaries break apart into subregions. So for example, when looking at a visualization from the world view, countries are displayed. And then as the user zooms in, states are displayed. The same effect can be achieved with clustering. As the user zooms in, clusters will break apart into individual points. And it also lets you hide layers at specified zoom levels to make high volumes of data much more readable. And so going back to what I mentioned about Power BI, if you've ever wanted to display a point or cluster data on top of an area or choropleth map, MicroStrategy may be the option for you. It lets you display area maps with boundaries at the same time as cluster or point visuals, and we'll go through some examples of these shortly. And the other way MicroStrategy really excels is its native advanced data join techniques. So BI platforms can rarely be 100% accurate when aggregating client-side data into geographical regions, and this can often result in missing or inaccurate data reporting. But MicroStrategy comes pretty close, and it also, which is really awesome, lets the user know when something is wrong. And we'll see these features in two examples. And so going back to the initial question I posed at the beginning of the webinars, one of them was, I can't display all my data on the same map. MicroStrategy is a great tool for helping with this. So in this example, we have 4 different layers simultaneously displayed on the map. It's earthquake data, and we have a layer for magnitude of earthquakes, number of quakes, and then we're also visualizing this in the context of boundary data within countries, and then a subset of each country within states. So when I add this geo attribute to the country name, MicroStrategy will intelligently look at the country name and group, aggregate the risk factors for these individual countries and display that on the map. And then it can also modify the tooltip and customize which information is in the tooltip as well. But what I think makes MicroStrategy so great is the finite control and the map options here. So as you can see, the map is overwhelming with all this data available at the same zoom level. So we want to control this. And so here, we're selecting which layers are available at which zoom level. So country level layer will be available at the world view. States will be available at the state view. Quakes will be available between world and state. And at the lowest level, you'll see the magnitude of each state. And so what that looks like is that the data starts to become much more readable. And so I wanted to pause here for a second. And so what I'm about to show you is how you can have even more finite control over individual levels. So here we're seeing, these dot layers, which are kind of unreadable. And so you can go into and format individual layers and actually control where individual layers start to cluster. And so here we want to display clusters at the world level. And then as we drill down to the state level, we want the points to break apart. And then finally, when we drill down into the street level, that's when we want to display the magnitude point. So MicroStrategy has done a great job in being able to control what data and how the data is displayed at different zoom levels. Okay. The other thing that MicroStrategy does really well is resolving these location conflicts. So as a developer, one of the most challenging aspects of creating your own BI data visualization is doing client-side data join. It's taking a customer data set that you might not know a lot about and figuring out how to take one geolocation attribute and then intelligently determining which polygon or boundary this data belongs in. And so I'll give you a quick example about why this is a problem. 32 out of 50 states have a Washington County, and 26 out of 50 states in the US have a Jefferson County. And so when you drop county name as the geolocation attribute, how would the product know which state or which county and which state to put the data point in? And so MicroStrategy has really gone a long way in solving this problem. MicroStrategy allows you to specify a second geo attribute, which will be combined with the first geo attribute to make the decision. And the other thing that I really love about MicroStrategy is it tells you when some of your data might not be good, or you might have some duplicate matches. And then it tells you exactly what you need to do to fix that. And so this is saying you can add more geo attributes in this drop down to better define the results. So let's go ahead and do that and see what happens. So we're going to now add in country, and that data duplication drops down to 4%. And then when we reorder the geo attributes to align with our layers, that number will drop down even further. And so that's really powerful for making sure that your data is 100% accurate. The next thing that we're going to show here is how the intelligent drill down works. So you can see before we set this country level layer to be available at the world view, and then as we drill down, we want to see the city layers. And so what that's going to look like is when we select an individual country, it auto zooms to that country, and then when we zoom in, it's going to intelligently drill down to states. There's no need for the user to actually click a drill down button in this circumstance. We're kind of making the assumption at what level the user wants to end up seeing those cities at, and then it works across different countries as well. So now we're going over to Great Britain and drilling in here, and we're seeing the same sort of workflow. So good job, MicroStrategy. Really cool Mapbox implementation, some really good enterprise features there. And so the last BI integration I'm going to talk about is Tableau. If you're a Tableau user, you probably know that Mapbox provides the base maps for Tableau. You can also create your own map styles in Mapbox and import them into Tableau. But we've got some new exciting tools which greatly increase what you can do with Mapbox and Tableau. So in case you didn't hear it this year, Tableau made a pretty big announcement at the Tableau conference, which is that they're moving to vector maps. So currently they're using rasterized maps, and this view to vector maps will do a couple things. It will bring significant performance improvements and user experience to maps in Tableau. The mapping, zooming and panning will feel faster and more fluid. One thing about vector tiles is they allow for infinite intermediary zoom levels between zoom levels, while rasterized tiles, you have to kind of load in a new tile set and map elements that render perfectly. And then vector tiles allow for style and layer changes to occur on the client side, which will reduce network trafficking. And Tableau is currently working hard to roll this out, but you can try it today. And the way that you can do that is through the Mapbox extension for Tableau. So it's an extension which comes in the form of a T-Rex file, and you can download that from Mapbox and upload it to your Tableau dashboard. So we built this extension, and we're providing it to the Tableau community, something that we're very excited about. It was the brainchild of a fellow solution engineer of mine, Chris Toomey, and he's been part of the Tableau community for a long time. So I think he's been getting some solid feedback from everyone and creating a really awesome product that addresses some of that feedback. And he also created some of the demos that I'm going to show you, which leverage the extension. So if you're out there, thank you, Chris. And so the key differentiator when it comes to the Mapbox extension for Tableau when compared to some of the other data visuals is our ability to do some more advanced geospatial analysis. And our extension is really our first foray into that. And so our goal was to give the community access to new tools and visualizations to get a sense of spatial distribution, to see how data moves across space. Because it's really important not just to look at points and size of points. We wanted to go above and beyond that. Because I mentioned before, choropleth maps, kind of tend to bias themselves towards population density. And so here are some of the things that you can do with the Tableau extension: clustering, grids, hex binning, extrusions, Voronoi analysis, isochrones, and data elevations as well. And we'll walk through those one by one. And so the first one I wanted to show was clustering. This is kind of the most basic example of geospatial analysis. Clustering is really just an algorithm for taking points across a specific area, and when data is closer together, they group or cluster. And you can see as you zoom in and out, data becomes more and less clustered together. Clustering is really useful for things like large data points, a large amount of data points, to see how they group together and to identify area of density. But this is really important as clustering wasn't available in Tableau before this extension was released. And so this example shows traffic volume in Toronto. And as you would expect, you kind of see high traffic volumes in downtown areas. And so this really served as a great introduction, but we wanted to go into some of the more advanced spatial analytics features. The first one is grid analysis, and grids are what it's doing under the hood is just taking the bounding box of your data points and creating grids on them and creating cells. And then we take the data underneath each cell and do a calculation on them. And there's a variety of different metrics or aggregation functions that you can calculate on. We do sum, min, max, count, mean, and median. You're also able to change the grid sizes, specifying units of miles, kilometers. The grids will be recalculated on the fly when you make those updates. And we also offer full control over visualization styling, like color. We can also view the data in terms of hex grids or bins, and this is just really a different way of looking at grid. It's just a preference point, but you can see that when looking at things in terms of hex binning, it offers less areas where there's no data. But what's really challenging about viewing data like this is that the color is hard to interpret. We have a legend which can tell us the range of values, but it's tough to tell the difference between colors that are closely matching together. So, for example, what's the discernible difference between two similar colors? And so we built another feature which accounts for that, and we call it the awesome button. And when you click the awesome button, what it does is it takes the value of the cell plus a constant, which is configurable, and the constant will just help you get some range and add some differences to the different extrusions. But what it can do is it allows you to compare those different cells a lot easier. So instead of comparing colors, you're comparing heights of the cell, which is at least a lot easier for the human eye to interpret. And so the key difference between this feature in Tableau and the one that you saw in Power BI is that in Power BI, you're extruding out a shape or polygon where the metric is, the underlying metric and the polygon is already aggregated. But with Tableau, you're extruding more based on spatial analysis of nearby latitude and longitude points. So with Tableau, we're taking groups of latitude, longitude points and binning them into hex bins and extruding those, whereas in Power BI, we're extruding based on a similar attribute between different data points. And now you can see the difference in elevation changes are much easier to decipher than differences in color. Okay, Voronoi. And so don't get intimidated by this. I actually didn't know what it was until Chris Toomey taught me at Mapbox. But Voronoi is a way of showing how much space is owned or occupied by any given group of points. And so it shows the space, which is no further and no closer than any other point. And so we don't have a Voronoi on the screen yet. I'm going to put it up soon. But it ends up being like this weird mural or fractal image. What this visualization does a really great job of is getting a sense of space, marketship, ownership, or command of a specific territory. So here we're looking at a distribution of Starbucks across the US, and we'll go ahead and show you what it looks like when we transform it into Voronoi. We go to this configuration option right here. We select Voronoi from the data dropdown, and then we get this weird fractal image here. And so you can see this is a number of lattes sold, and these are kind of centered around some of the major metropolitan areas. And so when we click on New York, it's going to cut this new fractal image for New York City. And you can see that the number of lattes sold are kind of tend to group towards downtown Manhattan and Midtown. And then we can select Chicago, and it does the same sort of analysis here. And so if you're trying to make a decision about which market you want to open up a new coffee shop in, maybe it makes more sense to open up where there's this void, this area is kind of void of coffee shops. And we can see that clearly from the Voronoi analysis. And so the next thing that we're going to talk about are data elevations. And to think about what a data elevation is, just like on a map where you have concentric lines, which the closer together they indicate a steeper change in elevation, we're also thinking, why couldn't we do the same thing with data and create a viz type which shows how much a metric changes over space? And so grids, as you can see here, are a good way to start. You can see some of the distribution, but we wanted to add a little bit more analytical rigor. For example, we don't know anything about these empty spaces here. Maybe the data is missing, or we kind of want to figure out what's going on here. And so what the data elevation feature is going to do is interpolate this data using a function called IDW, or inverted distance weighting, to come up with what that data might look like to help understand change. And so this data set here comes from ACLID, from a workbook called The World's Most Dangerous Places, created by Mike Cisneros. So if you're out there, thanks, Mike. I wanted to give you a shout out. And we're looking at violence against civilians in the Middle East, which is kind of a hot topic right now. So we're going to change this visualization to data elevation. The extension is going to go through a couple steps. It's going to grid the data, it's going to interpolate it, and then it will come out with something called with some isobands. And let's see what that looks like. And so here you can see we've created some isobands where data is grouped into a similar amount of aggregated into violence against civilians, and then we can change the amount of bands to 10 to kind of make the data a little bit more granular. And so you can see here we're kind of having a similar problem as we did with the hex bin analysis, where we don't really know what each of these bands are. It's hard to tell, what was the level of violence in the red zone versus a different shade of red zone. And what we can do that is use the awesome button again to create a type of extrusion. And now those differences will become a lot more apparent. We're just going to set the relative extrusion height here to make those differences pop out a little bit more. And then we can see a lot more differential between these different areas. But this visualization isn't perfect yet. We saw from the initial visualization that there wasn't really anything going on in some of these areas or on these plateaus. Maybe there was a singular event with a high data point, which is causing some bias in these huge areas. So we wanted to provide a way to account for that. And so what we can do is, instead of summing across these regions, we're going to use a different aggregating formula. We're going to change it to use the mean. And then we'll see what that data looks like after we update sum to mean. And so this really washes away a lot of the way of the bias, and we can see, I guess what the news is reporting, but that there's this extreme level of violence somewhere between Syria and Iraq, and it's literally, I think Chris Toomey, I don't know if he coined the term, but plateau of death, which is a little bit sad, but it's true, and this is where we know where. ISIS is probably hanging out. So it's a powerful visualization to view this data. Okay, on a lighter note, I wanted to talk about isochrones in Tableau. And so isochrones is another fancy word, but it's not, the concept isn't too complicated. It reflects the total area you can reach within a given time and mode of transportation. So if you're trying to answer questions like, what kind of foot traffic can we expect for a store at this location? If we put a bus stop here, how many riders will live within a 5-minute walk? How many homes can a firehouse serve within a 10-minute drive? These are the types of things that we can analyze with isochrones. So in this example here, we created, before we went to the Tableau conference in New Orleans, we wanted to see kind of where our conference attendees could walk from the conference center. So you can see in the UI here, it's taking in a travel time. You can select bicycle, auto, bus, HOV, motorcycle, pedestrian, and then you specify the amount of concentric rings that you want and the amount of time between each concentric ring. So here, we're going to select 4 concentric rings of 5 minutes, select a data point here. This is where the Tableau conference was here. And then this data is looking at fish markets and how many fish markets are within a 20-minute walk of the convention center, because I guess we all wanted to eat fish. So you can see here there's really no data points in here. So what we can do now is expand the radius of those circles. Let's do 4 concentric circles of 15 to see what's in an hour walk, because after all, we were in New Orleans, and after eating that New Orleans food, we could use some exercise, and then you can see that now there's much more data in the isochrone bands. And so there's a lot of great use cases for something like this. One that I've seen come up a lot is real estate companies. They want to create walk scores, or they want to score different buildings on what's close by. For example, how many schools are within a 10-minute walk, how many modes of public transportation are within a 15-minute walk, or how many health providers can I get to in under an hour, which is kind of the golden hour for a golden hour and a key metric for being able to get access to good healthcare. And so quickly, I just wanted to show how you add the extension to your dashboard. You can download it here. We'll provide that in a document to the conference attendees following the webinar. But basically, you download it from the website, and then you can drag and drop it into your BI dashboard to the extensions UI. And so so it's pretty easy to do. It might just warn you quickly that you're importing a third-party visualization, and that's okay. You can trust us. Cool. And so those are the 3 BI tools I wanted to talk about. And then quickly, I just wanted to talk about some tools that you can use to create your own location visualizations. And so while we have some pretty amazing tools available in these BI tools on the market, Mapbox also caters to developers who may be wanting to create or code up their own data visualizations inside their own application. Traditionally, these types of visuals have been difficult to create, maybe requiring hundreds of lines of code and complex logic. But we've been partnering with companies like Uber to create developer-friendly frameworks, which allow you to create some beautiful and meaningful data visualizations in just a few lines of code. So I'm going to show you some examples of these visualizations. You can also get some links to the source code as well. But we're using a framework called Deck.GL, which Uber created on top of our Mapbox GL.js framework. And so one thing that you can do with Deck.GL is create great arc circles. This visualization is showing US migration patterns between cities, and you can mouse over each city to visualize the volume of people moving to other areas of the US. Blue lines indicate net migration to a city, while red lines indicate net migration out of a city. And then you can see users can see those labels above their data. Developers can create this visual by adding a Deck.GL layer at runtime. And so you can see this is a basic amount of code to get a visual like this. This isn't the exact source code of the visual, but we can share that after the fact. But you can add these complex data visualizations in just a few lines of code. Another example of how you can use Deck.GL is to create hex bins. So similar to here, where we saw adding a type of arc layer here and a couple parameters, you can add in a type of hex bin, and then you can specify your style parameters, and you can create really amazing visualizations like this, which can handle a really extreme amount of data. And then the last thing I wanted to talk about with Deck.GL was how you can add 3D imagery into your data visualization as well. And so you can see how detailed that gets. But prior to custom layers, developers had to manually work with coordinate matrix and projections to synchronize 2 WebGL canvases on the map and the 3D model. But now developers can really control exactly where the model is placed in the scene, and then Mapbox will handle the synchronization of the model while the user pans and zooms. Getting started with Deck.GL, you can check out this blog by Ryan Bauman. That will also be included in the follow-up. There'll be links to sample code in there as well that you can check out and see exactly how those great arc, hexbin, and 3D imagery visualizations were created and how easy it is to do. So that concludes the webinar today. Thank you all for listening. I hope you found it helpful. I hope you learned some cool new visualization techniques that Mapbox is supplying to the market in popular BI tools. And then I also hope that it piqued your interest in case you want to start, writing some code and developing these visualizations yourself, which is a pretty awesome thing to do. So you can expect a follow-up email from us with the links and information which is included in the presentation, and that's it. Thanks, everyone.